Okay, good morning. Welcome to
FamilyMath530.
FamilyMath530. Actually, you need to come over here so you can use the mouse. This is a shape I made. Right now we're going to look at it on the computer. If you look at the code, let's look at the code first, which I should have done with your brother, and then we can zoom in just on the shape. So I make a cylinder by not in the normal XYZ direction, but I flip Z and X. Do you see that?
All right.
And then on this one I flip Y and Z, but all that does is make two cylinders that are going in perpendicular directions.
Okay.
And then what does it do? Do you remember what this does when I take the difference between one and the negative above the other one?
That gives you the area. That gives you the space where they intersect.
Yeah. Yeah. So this is. I can zoom in a little bit on it. This is the intersection of two cylinders. So tell me what you think about the shape.
Well, I mean, we've done a project on the intersection of 3 cylinders, and I see some similarities here.
Oh, okay. What do you see?
Look, on our 3 cylinders project, there were a bunch of these, like, X shapes.
Okay.
But there's only this one here. And this one actually is a lot more curved, and you can sort of see the cylinders. Were the cylinders, like, ovals, or were they squares?
No, they're
or
circles.
The circular base.
Yeah, they were circles.
Oh, Alright.
So the reason I'm doing this, I wanted to talk to you about the shape, is this shape is a very common shape on college calculus question, in college calculus classes, a lot of times on exams, maybe just as like a homework problem though. And the question is to try to calculate the volume of this shape. But you don't know how to calculate the volume of this shape.
No, I do not.
But do you see anything in the shape that you think might help you with that? Any shapes that you can use?
I mean, like, when I have it right here, you sort of have a square.
Alright. Do you see any other squares?
Well, it's not really a square, I mean, the other way you look at it.
Tell me the square you saw.
So, the square, it's made by these lines, which don't actually exist, but they're on these curved faces.
Okay. Do you see any other squares?
No, just from here anywhere.
How about from there?
No, though I do see a lot of triangles. I see four right triangles.
I see 4 right triangles. Okay. Well, let's take a look at the slicer. So this is slicing up and down the shape. What do you see here?
It looks like it's a bunch of squares put together.
Okay, so click back on the red.
So it means that there'd actually be an infinite number of squares here.
Where's one of them?
But like, it'd go.
Okay, do you see that square now?
Yeah.
Okay, and where's another one?
Go like here.
Okay. So it's not just the square that you saw on the outside. There's actually lots of squares here. And that kind of helps you calculate the volume because you know how to calculate the area of a square.
Yeah.
And you can imagine this being sort of a stack of very thin boxes that are squares and then a little bit tall.
Yeah.
And then you just add them up. So that's actually pretty neat. So now we're going to actually take a look at the 3D printed version of the shape, okay?
All right.